Hello students. So today we will see the continuation of the previous class. That is, in the previous class I had explained you what is meant by proportion and some connectivities. So what are the connectives we are going to use in proportion? One is not, another one is and, another one is or, then the fourth one is if then the fifth one is if then else, if and only if. Okay. Today we are going to see the compound statement. So, if you have, let us have one example. If you are having a p value as my program runs, as shown in the slide here, and q represent my program contains mistakes. So, write the expression for p and not q or q inverse. So P represent my program runs, not Q means my program contains no mistakes, and again Q means my program contains mistakes. So here it is and, we need to make it as and like this. My program runs and, we need to use and, it contains no mistake for the negation. Then we need to use or. So this one is comma, or my program contains mistakes. Okay, this statement you can write it in both the way, that is either my program ran and it contains no mistake, or my program contains mistake. Both are incorrect. Notice in the first sentence we use the comma because to separate the part of the compound statement that is inside the bracket. In the second sentence we use the word either in addition to the comma to emphasize this separation clearly in English than logic. Okay, this is more a matter of writing clearly in English. So compound proportion means more than one connective can be used to connect the proportion. The truth value of such a compound proportion can be determined by using the truth table of a basic connectives, which is discussed in the previous section. So as we seen early, the same example I am showing here. So if your my program, if P represent my program runs and R represent my program contains no bugs, then your statement will come like this. Please note it. The opposite of this is P and or not or. Instead of not here, you will have not or here. Okay. The next, this is, take it as this one as a homework. I gave 4 problems. For this 4 problem, you need to form a symbolic logical expression for this 4 statements. Okay, take a screenshot. Shall I explain you the deep problem here? If Ahmad is happy, let we have small p represent Ahmad is happy. Let we have P like this, and Q represent Amir is happy or not happy. It's up to you. Okay, shall I take Amir is happy? Okay, so in the statement Ahmad is happy, so we can take it as P, and they have using if then. Okay, Amir is not happy. If Ahmad is happy, Amir is not happy. Okay, Amir is not happy means we need to use the negation. And if Ahmad is not happy, means negation P, comma, Amir is not happy. So implies Amir is not happy means negation Q. So like this we need to express in a symbolic logical expression. Okay, please do the remaining 3 problems. I hope that all of you can understand. So I am going to explain you the next one. Okay, the next homework problem. Here, if P represents summer in UAE is very hot, and Q represent people staying inside. Okay, I will explain you some problems here, and remaining thing you can take it as a homework problem. Okay, this one and this one. Some people having doubt in C. Okay, I will explain you. Here P represents summer in UAE is very hot. So summer in UAE is very hot, or people not stay inside. This is for P or not Q, but they are taking the negation, so we need to do the negation for this statement. How we can take summer? So not during the summer in UAE is not very hot, or people will stay inside. Okay, and it will come and. So this statement is not true for summer in UAE is very hot or people not stay inside. That's the meaning. Okay, so we need to take negation for this. For that I need to use the negation of this one. So it's not true here. Okay, for the D, how we can use negation of P means summer in UAE is not very hot. Here we need to use not very hot. And not Q means people not stay inside. So if summer in UAE is not very hot, then people not stay inside. Like that we need to use for D. And for G, we need to tell summer in UAE is very hot and we can say summer in UAE is not very hot or people stay inside. Okay, this is in a group. Then we can do. So like that, so you need to translate it in words. Now, how to construct the truth table for the following logical expression? So I will explain you for this one. Okay, so we need to take the P value. Okay, only one this one I am going to explain you. The truth value P, Q. So there is another expression also. So it comes as lengthy. I will go for D instead of E. So Q. Then I need to take negation P. Then P implies Q. Then I need to go for P implies Q or negation P. Okay. So for P we need to take true, false, true, 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 false, false, true, false, false. Then for negation P, we need to take the negation of this P. So false, false, true, true. Then I need to take P implies Q. P implies Q, when it becomes false, true implies false means it becomes false. So true implies false is here, so everything will become true. Then we need to take P implies Q or not P. Or not P. If both the one is false, you will have false for or. Okay, if anyone become true, then it become true. So for this only both are false, so it become false. Everything remaining thing will become true. So this is a truth table. This is the result of a truth table for the problem D. So likewise you need to do all the problem for the 3 variables. I will explain it later in a separate slide. Okay, it will become a lengthy one. So please try for the 2 variables, that is, please do all this problem A, B, C, D. Okay, E and F I will explain it in a separate PowerPoint. Okay. Okay. Okay, people are asking to explain it now itself. So I will explain you. So P value, Q value, R value. I am explaining the E problem. If it is 3 value, you will have, so how you can take it? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, you know the binomial. Then 1, 1, 0, 1, 1, 1, 0, 1. Okay, so totally you will have the 8 values. So replace 0 as false and 1 as true. Okay, so true, 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 false, true, false, true, true, false, false, then false, true, true, then false, true, false, then false, false, true, then at last you will have false, false, false. Okay, so 3, 4, 4, yes, 8. So next thing, we need to take the negation of OR. So negation of OR, we need to take the negation. So false, true, false, true, false, true, false, true. Then we need to take P or not or. P or not or, we need to consider these 2 columns. So for OR, if true comes, you will have true. So true, 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 but here false. Here true, false again, here it is true. Okay, next thing, implies. P or not or, and then implies Q. You need to go in this direction. That is, for true false you will have false, otherwise it becomes true. So this is P or not or, if and only if Q. Oh, if and only if Q means if both the truth value is same, then you will have true, otherwise it is false. So both the ones should be true. So it becomes true because both are true here. Next thing also true. Next thing become false, 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 true. Here also true. Here it become false. So likewise you need to do for the 3 variables. Hope you can understand well how to construct the truth table. Do you have any doubt, students? If you have doubt, you can ask me. Okay, the remaining thing you need to do by yourself. The next thing, what is meant by tautology and contradiction? So I had explained you how to construct a truth table before, no? By using the same method, we can prove whether the given logical expression is a tautology or contradiction. So tautology is a logical expression, is always true regardless the truth value of the involved proportion. It's always gives you the truth value true, but contradiction gives you the truth value false. Okay, if the logical expression B is tautology, then negation B is a contradiction and vice versa. Okay, let me consider one example. Show that the logical expression, this one is a tautology. You know how to use the truth table. I had explained it before. So first of all, we need to take P and Q. The next thing, we need to write down P and Q, then take a negation of this, and then take not P, then not Q, negation Q, then take both the one, the OR, then after that the whole expression comes all or two here, therefore the given expression is tautology. The next thing, next example, prove that this example is a contradiction. First of all, we need to find out P and Q, then take the negation of P, and for both the one take and. So you are getting the value as all are false, therefore the given expression is a contradiction. It's very easy if you know how to construct a truth table. So this is a homework for you. Determine the following logical expression is tautology, contradiction, or neither. So neither means you will not have all the value as t and all the value as false. In that situation, it comes as neither tautology nor contradiction. As I had explained it before, some truth table, no, how to construct truth table. In that situation, you didn't have all or true and all or false. So in that situation, I can say that it is neither tautology or nor contradiction. Please take it as a homework problem. Okay, I will explain you what is meant by logical equivalence in the next table, next class, and also I'm going to explain you the laws of logic. Okay, see you. Bye bye girls. Sorry, bye bye students.